These are the non-renewable resources notes, and then we'll continue on and do the alternative energy notes. Resources and their uses. You've got a little chart to fill in with these types of things. Sand and limestone you can use for building. Salt, use on foods, roads, and chemicals. Talc, remember, is the softest mineral. You use it in talcum powder, baby powder, and paints. Sulfur was that egg-smelling paint. And so the sulfur can use in a fungicide and as an acid. Graphite, dry cells and lubricants, and then phosphate for fertilizers. And then on your graph, you need to fill in the axes, the time and years on the bottom, and then the millions of barrels per day up the y-axis. And right about where we are, right here, we're pretty much at our peak use of oil or petroleum. We can't really use any more now. We need to start decreasing. And there is a limit to our available resources. Not all reserves are in the states, and that leads to political problems. We should hopefully know that the Middle East has most of the oil reserves. That's why we're having so many problems at the moment. And then Russia, and then Mexico, and then Libya, and then here we are, the United States. We have this teeny tiny amount of it. And the two types of non-renewable resources, minerals, metals and nonmetals, and then fossil fuels. What is an ore mineral? A valuable element that's commonly combined with other substances and will need to be chemically separated. Usually the element that is attached to a rock, and if there is enough of the mineral to be profitable, we call it a mineral ore. Some other important ore minerals: gold, copper, iron, zinc, aluminum, nickel, and then a whole bunch of other ones. And then we've got some non-metals like sand, gravel, salt, sulfur, graphite, and talc. And then the fossil fuels. We rely on fossil fuels to supply most of the world's what? Energy. And then what is energy? It's the ability to do work. What are fossil fuels? They're formed from plants and animals. And then the three main examples are coal, oil, and natural gas. In the formation of fossil fuels, a dark-colored organic sedimentary rock formed from large quantities of decomposed plants in times when oxygen is low is the most commonly used fossil fuel, coal. And there are four types of coal. You guys remember what they are? Peat, the organic matter, and then as the peat moves along in the cycle, it becomes lignite. Lignite becomes bituminous coal, and then anthracite coal after that. And remember, anthracite gets an A for being the cleanest burning coal, because it has the most carbon. And then what's coal used for? A sedimentary material of organic origin, a mixture of hydrogen and carbon is also known as rock oil, which is petroleum. And then a mixture of hydrogen and carbon gases, mostly methane gas, is natural gas. 2/3 of all of our energy comes from oil. How does petroleum and natural gas form? You know? Organic material becomes compacted. Hydrogen and carbon, called hydrocarbons, are squeezed into pores and cracks of nearby rocks. The lighter oil and gas rises above the seawater and is collected. Why haven't the oil and gases escaped from rocks before it had time to form? The petroleum and oil rose up until they reach a layer of rock that is impermeable, called a cap rock. The most common cap rock is shale. And then some of you guys remember this picture. It was on your review guide. And you've got the shale, which is impermeable, another layer of shale that's impermeable. And then the permeable sandstone, you've got water down here, it's water saturated. And then the oil, and that's why the well is drilled down into the oil. And then you get the gas that's trapped on top. And then the formation of fossil fuels. What are some common uses for petroleum or for natural gas? Got all these pictures here to help give you some hints. Some of the environmental issues with these things. Mining. Strip mining destroys land and leaks sulfuric acid. Essentially, they have these machines that just come in and literally scrape off the top of mountains. And then they mine in the mountain and then just kind of leave it. Mining, regular subsurface mining, can collapse on top of the people when they're inside. And then radioactive waste and the Chernobyl nuclear explosion happened, I believe it was 1980, and it was in the 80s. And then burning fossil fuels releases carbon dioxide, which creates global warming. And then sulfur dioxide, which creates acid rain. And then some more environmental issues. We're talking about destroying the land, oil spills in the ocean. We just had the other one in the Gulf of Mexico here recently. And then what's called eutrophication, which is the algal bloom from the fertilizer, which we'll talk a little bit more about in Chesapeake Bay. And then all these problems need to be globally fixed, and we are working on them more than we used to be, but it's still not quite enough just yet. Here are the alternative energy sources. Nuclear energy, solar energy, water energy, which is also called hydroelectric, wind energy, geothermal energy, and biofuels. With nuclear energy, nuclear fission is the splitting of the nucleus of uranium-235 into much smaller nuclei. The splitting heats the surrounding water, which becomes a source of energy for running electric generators. The fission of 1 gram of uranium releases as much energy as 3 tons of coal, which is 14 barrels of oil. But the dangers include that the waste needs to be disposed of properly, or it will kill plant and animal cells. Nuclear fusion is the small nuclei to combine that form one large nuclei. And you can see here in the picture, you've got 2 coming together to form 1. And then you have this extra neutron that gives you some energy. The energy from the sun is produced this way, which we'll talk about a little bit more. You get 2 hydrogens that come together and form a helium. And then again, here's the energy from the sun. Solar energy captures light from the sun to heat water and produce electricity. The problems that are involved with this is the fact that it's very expensive to install all of these solar panels. And of course, what are you going to do at night when it's dark outside? You can't use solar energy at that point, only on sunny days. And then energy from the water. Hydroelectric power is generated by damming water and releasing it at certain times, creating electricity. And it can only be used in certain areas with rivers that are suitable for damming. If you think about this whole thing here as a river, they build this dam here, and then you're keeping water on one side, and then they'll open the gates and let the water flow, and it'll turn this turbine right here, which creates energy, which they use and harvest. It is a good thing, sort of, in some ways, because it's low cost and there isn't any pollution. But the bad part to it is that if you think about the ecology in this area, what's going to happen to the organisms that live downstream when all the water gets sucked upstream? And then here's another picture. You can see it's dammed up here, and then they're opening, and then down here in the water is where that turbine would be spinning. Wind energy. Electricity generated by the speed of the wind against the blades of a windmill. Windmill farms are located in areas with consistent high-speed winds. And the governor, actually, recently, has been trying to get the state of Virginia to put windmills off the coast, out in the ocean, still in Virginia waters, though, to harvest some energy. And we'd be able to use that to power some of the places in the state. Geothermal energy. Geothermal energy captures energy from the water heated from Earth's internal processes. Remember, we've talked about the deeper you go down in the Earth, the hotter it is. And then here you've got a geyser related to the geothermal energies. And it's used mainly in Iceland because that's right on that mid-Atlantic ridge where the tectonic activity is happening, and that's the ridge exposed on the surface there. So there's a lot of tectonic activity happening there. So it's easier to use there than maybe in an area in the middle of a tectonic plate that doesn't have any of that activity. And heat from Earth's interior is converted to electrical energy when steam or hot water from below Earth's surface is piped to a power plant to run a generator. It's usually found in volcanic areas. There are 22 countries around the world that have geothermal plants. And biofuels is defined as solid, liquid, or gaseous fuel derived from relatively recently dead biological material and is distinguished from fossil fuels. If you've ever heard of anyone converting their vehicle in order to run on used oil from like French fry places and that sort of thing, these fast food restaurants, people have actually done that, and that is considered a biofuel.